For this video, we will be talking about sections 7.3 and 7.4. Both of them consist of solving systems by elimination. So we will start out by using addition and subtraction, and then we will move into using multiplication to solve systems by elimination. So to review really quick, we have learned two methods so far. You have learned how to solve systems by graphing, and you've also learned how to solve systems by substitution. We had three possible answers for each of those methods. If it was one solution, if it was by graphing, it was when two lines intersect at one point. By substitution, when solving, you get x equals a number and y equals a number, so then the answer is an ordered pair x comma y. If it was no solution, by graphing, it was when the two lines were parallel. They have the same slope but different y-intercepts, and I just realized I forgot to close that parenthesis there when I typed these on here. So let's go ahead and close that. And then by substitution, you get your variables cancel completely out, and then the equation is not a true statement. For example, 4 equals -7. Next one, you have infinitely many solutions by graphing. This would be when the two lines coincide or they are directly on top of each other. They have the same slope and the same y-intercept. And then by substitution, again, the variables would cancel completely out, and then it would be when the equation is a true statement. For example, 9 equals 9. Okay, just to review some vocab here again, a set of two or more equations with the same variables is called a system of equations. That's what we've been working with this whole chapter so far. So again, we've done graphing, we've done substitution. Today we're learning elimination. So key concept for the elimination method, you need to look for one pair of variables, either x or y, that have opposite coefficients. So for example, 5x and -5x, those would be opposite coefficients. Think, it's elimination. You need two things to get eliminated when we add the columns together, and that's actually the process that we use here for elimination. So if you have opposite coefficients, we'll talk about what happens if you don't. Step 2 says you add the equations together, eliminating one variable. Then you solve the equation. So if we look at number 1 here, I'm going to pull off my keyboard. I don't know the sound it's going to make. It doesn't sound like it was too loud. Okay, looking at number 1 here, I see that I have opposite coefficients. These ones right here, 6x and -6x, they are the exact same number. One is positive, one is negative. That's what I need when I need opposite coefficients. So I'm literally going to draw a line here and put a plus sign because step 2 says you add the equations. So it's like adding big numbers together, right? We just add everything straight down, and actually you don't have to go from right to left. We're just going to go from left to right here. So 6x minus 6x or plus -6x, it's the same thing. They cancel out. We have -3y plus 5y would give us a 2y, and then equals 3 plus 3 would be 6. Then from here you have a one-step equation. So divide both sides by 2, and you get y is 3. Now, this is where it's very similar to substitution. From this point, once you have what y is, we're literally going to plug it back in right here and solve for x. So then I'm just going to plug it into that top equation. 6x minus 3 times y would be times 3, and then equals 3. I'm going to scroll down here just a little bit. So then I have 6x minus 9 equals 3. Add 9 to both sides. So then I have 6x equals 12. Divide both sides by 6. Sorry, my x got a little cut off there. So then my answer would be x equals 2. But then again, you have to have a final answer of an ordered pair. So then this would be 2, 3 for our final answer. So again, the last part of elimination is very similar to substitution. It's just the first part that would be the new idea here. So again, looking at number 2, first question is, do we have opposite coefficients? It could be x or it could be y. So 2x and 6x, those are not opposite coefficients, but I see that 5y and -5y are definitely opposite coefficients. So I'm going to go ahead and draw my line and my plus sign to remind myself that I am adding the columns together. So then 2x plus 6x gives me 8x. And then 5y and -5y, that's where they would get eliminated. And then I have equals 17 minus 9 would give me 8. And then from here we continue solving. So I'm going to divide both sides by 8. and I get x equals 1. And then again, we've got to plug this in into either equation. I don't think I stressed that on the first example. You can plug x in for the top equation or the bottom equation. I typically, just being a creature of habit, like to just go with the top one. I really don't have a good reason for you. Some people like to look for the smaller coefficients, and that would be the one that they would rather plug it into. Some people look for equations that have all positive numbers if they can help it. So some people have different reasons for why they pick different equations. I just typically go with the top one. So then when I plug this in, I have 2 and then times 1, because that's what x is, and then plus 5y equals 17, multiply 2 by 1, and we get 2 plus 5y equals 17, subtract 2 from both sides, and we have 5y equals 15. Divide both sides by 5, and we get y equals 3. And then last step would be to write our answer as an ordered pair here. So 1, 3 in parentheses would be our final answer. Okay, that's it for numbers 1 and 2. So before we go to the next page, though, I do want to just highlight real quick this right here. If there are not any opposite coefficients, we're going back to step 1 here. So you're looking for opposite coefficients. If there are not any, you will need to multiply at least one of the equations by a constant or a number to get 2 equations that contain a pair of opposite coefficients. So we're going to talk about that on the next few pages here. So let's go ahead and flip to the next page. Okay, on page 2 here, we have number 3. I see 7x plus 2y equals 10, and then 7x minus y equals 16. Again, remember, step 1 is looking for opposite coefficients. So looking at this, I see that I have 2 7x's, but right now, if I add them together, that would give me 14x, and that's not what I want. I want them to get eliminated. So the problem is they're both positive. I need one of them to become negative. So what we're going to do is multiply either the top equation or the bottom equation. In this case, it truly doesn't matter, by a -1. If all I need to do is flip the sign, remember that -1 would keep the number the same. It would just make the entire term negative. So I'm going to go ahead and multiply by -1. Notice I put parentheses around the entire equation. We need to distribute this -1 to all 3 terms inside of the parentheses to keep it as an equivalent equation. So if I do that, I get -7x minus 2y equals a -10. Now, something else I like to do is I like to just kind of give this a light little squiggle through so that I don't look at that equation anymore, because now that I've multiplied by -1, I need to make sure that I'm adding these 2 equations together right now. So I'm going to go ahead and draw my line and put my plus sign. I'm not using the top equation anymore. I'm using my new one, and then the other 7x minus y equals 16. So when I add these together, now my 7x's cancel out. I have one positive 7x and one negative 7x. That would add up to 0. And then if I keep adding here, I have -3y equals 6. So then if I divide both sides by -3, I get y equals -2. And then again, we have to plug this into either equation. And I still am just a creature of habit, like I said on the front page, and I will always go back to the top equation. Even though we squiggled it out, there's nothing wrong with that. As long as you can still read everything. So that's why I like to do a light little squiggle. That way, if I need to go back to that equation, I can. So then I would have 7x plus 2, and then times -2, because that's what y is. We're plugging that in now, equals 10. So then if I start solving, I would multiply 2 times -2. So 7x minus 4 equals 10. Add 4 to both sides, and we have 7x equals 14. Divide both sides by 7, and x would be 2. So then my final answer here would be 2, -2. Okay. Next, we have number 4 here. So again, looking for opposite coefficients. And unfortunately, in number 4's case, we don't have 2 of the same number. We just need to multiply by -1. We actually have all very different numbers. So this is the thought process that I like to use. So I'm going to get my laser pointer out here. I like to look at, if I'm looking at x's, I like to look at the smaller coefficient, so 2. Can I multiply something by 2 to get to 7? In that case, you'd have to multiply by a fraction or a decimal, and we really don't want to do that unless we have to, and we actually will never do that. So then I go to my y's. I have 15y and 5y. I look at 5 and I ask myself, can I multiply something by 5 to get to 15? The answer would be yes, you can. You can multiply 5 by 3 to get to 15. But again, if you're going to multiply the y term by 3, you've got to multiply every single thing by 3. So then here's the thing. The next thing you should look at is, do they have opposite signs? Because I don't want to multiply by a -3 unless I have to change the sign. So in this case, I already have a positive and a negative. When I multiply by 3, this is going to give me a -15y, and therefore will cancel out those two terms. So I'm going to go ahead and distribute here. I would get 21x minus 15y equals 51. And then again, I like to do a light little squiggle here. So then this is going to look funny, but I'm going to put a box around this one and a box around this one. These are the two equations that I'm using. So I'm going to draw my line here, put a plus sign. Negative 2x and 21x would make 19x. And then 15y and negative 15y, cross through those because they get eliminated. They add up to 0. And then negative 32 plus 51 would give me 19. Divide both sides by 19. And I have x equals 1. Then from here, I'm going to go ahead and plug this back into the top equation. So then we have negative 2 times 1. And then plus 15y equals negative 32. Multiply negative 2 and negative 1, and we get negative 2 plus 15y equals negative 32. Add 2 to both sides, and we get 15y equals negative 30. Divide both sides by 15, and y is negative 2. So then our final answer here would be 1, negative 2. Okay, next we have numbers 5 and 6. So looking at number 5, again, I like to go to the smaller of the two coefficients. So I look at 3. Can I multiply something by 3 to get to 5? In this case, no. Then I look at my y's. Can I multiply 2 by something to get to 6? And in this case, the answer would be 3. And then again, I check for the sign last. So they already have opposite signs. So I do not need to change the sign of anything. So I'm going to go ahead and distribute that 3. So I have negative 15x minus 6y equals negative 42. And then again, just a light little squiggle through there. And I am adding this equation in the green box to this equation in the green box. So I'm going to go ahead and put my line and my plus sign. When I add them together, 3x plus negative 15x, or 3x minus 15x, it's all the same, would be negative 12x. And then my 6y's cancel out, equals negative 6, and negative 42 makes negative 48. Divide both sides by negative 12, and x would be 4. And then again, just plugging it into the top here, I have 3 times 4 plus 6y equals negative 6. Then I would get 12 plus 6y equals negative. I just realized I said negative 6, but totally wrote 16. I don't know where that came from. Should be just a negative 6 there. Sorry about that. Subtract 12 from both sides, and I get 6y equals negative 18. Negative 6 minus 12 will give you a negative 18. Divide both sides by 6, and y would be negative 3. So then our final answer would be 4, negative 3. Okay. Looking at number 6 here, I see 3 and 5. I can't multiply something by 3 to get to 5. And then looking at 5 and 7, I cannot multiply anything by 5 to get to 7. So then the question is, what are we going to do? We're actually going to have to multiply both equations by something. So me being me, I like to choose the smaller coefficients. Just means hopefully we have smaller numbers to work with. So 3 and 5, the first number that I think of that they both could be multiplied by a number to get to would be 15. So I know my goal is plus and minus 15x. So looking at 3x, and I'm going to go ahead and erase the circle that I had here. so that I have room to add my little parentheses. Okay, so I know that I'm going to multiply the top equation by something and the bottom equation by something. In order to get from 3 to 15, I need to multiply by 5. And in order to get from 5 to 15, I need to multiply by 3. Now, the last thing you have to pay attention to is what signs they need to be. So right now they are both positive. That means I need one of them to be negative. It does not matter which one you choose to make negative. I'm going to go ahead and make this 3 the negative 3. So then that's going to get me a positive 15x on the top and a negative 15x on the bottom. So when I go ahead and distribute here, I have on the top 5 times 3x would be 15x. 5 times 5y would be 25y. And then equals 5 times 10 would be 50. A really common mistake that people make is they forget to multiply the 5 by whatever comes after the equal sign. Don't forget, you got to distribute to everything. Next, I'm going to go ahead and focus on distributing the negative 3 on the bottom. So negative 3 times 5x would give me that negative 15x that we talked about. Negative 3 times 7y would be negative 21y. And then negative 3 times 10 would be negative 30. So now we can go ahead and add these two equations together. So again, usually I would lightly scribble these out. These are the two that I'm adding together. So I'm going to go ahead and put my plus sign here. So my 15x's cancel out because one's positive, one's negative. They add up to 0. And then 25y and negative 21y makes 4y equals 50 plus negative 30 would be 20. So then divide both sides by 4. Y would have to be 5. Then I'm going to take 5 and plug it back in. Again, I just like to go back to the top. Even though it was squiggled out, we can still use the original equation here. So 3x plus 5 times 5 equals 10. And then we would get 3x plus 25 equals 10. Subtract 25 from both sides. 3x equals negative 15. Divide both sides by 3. And x would be negative 5. So then our final answer would be negative 5, 5. Don't forget, x has to come first. Okay, let's go ahead and move on to page 3. Okay, on page 3 now we have number 7. I see 10 and 15 and 3 and 7. So starting from the beginning, we don't have opposite coefficients here. Multiplying by negative 1 is also not an option because they are different numbers from each other. So then I look at 10 to 15. Can't multiply 10 by anything to get to 15, at least not a whole number. So then I look at 3 and 7. Can't multiply anything by 3 to get to 7. Again, not a whole number. It would have to be a decimal of some kind, and it would just be really, really, really messy. So we are going to have to multiply both equations by numbers. So between 10 and 15 and 3 and 7, I would rather focus on the 3 and the 7 because they're just smaller numbers. Hopefully it gives us smaller numbers in general to work with. Between 3 and 7, the first number that I would think of that comes to mind would be plus or minus 21y would be our goal here. So in order to get 3 to 21, I'd have to multiply it by 7. And in order to get from 7 to 21, I'd have to multiply it by 3. And then again, you have to pay attention to the signs. Both of them are positive right now, so I need one of them to be negative. And again, I'm going to go ahead and just make it the bottom equation. So when I distribute, 7 times 15x would give me 105x, and then plus 21y equals 63. And then negative 3 times 10x would be negative 30x. Negative 3 times 7y would be negative 21y, and then equals negative 3 times negative 4 would give me a positive 12. So when I go ahead and add these two equations together, again, these are the ones that I'm looking at. I'm going to go ahead and draw my line, put my plus sign, light little squiggle through those. And then 105x and negative 30x makes 75x. The 21y's cancel out. 63 and 12 makes 75. Divide both sides by 75, and x would be 1. Then we're going to plug it in up here. Again, back to the original top equation. Again, you can use either of the equations. You can actually also use the two equations that are in the boxes. Again, any equation would work to give you y. So then I have 15 times 1 plus 3y equals 9. 15 times 1 would just be 15, plus 3y equals 9. Subtract 15 from both sides. 3y equals negative 6. Divide both sides by 3, and y would be negative 2. So then our final answer here would be 1 comma negative 2. Okay, looking at number 8. So I'm looking at for opposite coefficients. I don't see that. I also don't see two numbers that are the same. So just multiplying by negative 1 is not an option here. So then I ask myself, can I multiply something by 3 to get to 12? And in this case, I could. I can multiply the bottom by 4 to get me to 12. Now, the other thing we have to remember is I got to pay attention to the signs. So if they're both already positive, that means I'm going to go ahead and multiply by a negative 4. So when I do that, I get a negative 12x, and then negative 4 times negative 2y would be plus 8y equals negative 4 times 5 would give us negative 20. So then if I'm adding the top equation, we're not looking at the middle one anymore, and the bottom equation together, if I draw my line and put my plus sign, 12x and negative 12x cancels out. Negative 8y and 8y cancels out. So here's the deal. You still have to have an equal sign. You still have to write something down. So if both things cancel out on the left-hand side, that would just be 0. There's literally nothing left. 0 represents nothing. 20 and negative 20 actually also cancel out. So again, still got to write something down on the right-hand side. So you actually have 0 equals 0. You have to make sure you write that part down. Don't just cancel everything out and move on from it. You got to tell me what it equals, okay? After this point, you have to ask yourself, is this a true statement or not? Remember, anytime variables cancel completely out and we have nothing left, it's either infinitely many or no solution. So does 0 equal 0? Well, in this case, it absolutely equals 0. So then this would be an example of infinitely many solutions. Okay, and then we have number 9. So I look at 9x and 9x, and I see that they are very, very, very close to being opposite coefficients. They're just not opposites of each other right now. And actually, the same thing goes for 8y and 8y. So that I know if I multiply, and again, you could do either equation. I'm going to go ahead and multiply the top one by just a negative 1 just to change the sign. So then I would get negative 9x minus 8y equals negative 15. So then if I drew my line here, put my plus sign, these are the two equations that I'm adding together. So I'm, again, just going to do a light little squiggle through that one. 9x and negative 9x, they cancel out or they get eliminated. 8y and negative 8y also cancel out. So again, if everything cancels out, I have to have my equal sign. I got to put a number on the left-hand side. So I'm going to put 0 here because there's nothing left. And then 30 and negative 15 makes 15. So then the question is, again, you have no variables. Is this a true statement or a false statement? Since 0 does not equal 15, you could put a line here if you wanted to. This would be an example of no solution because the two numbers are not equivalent to each other. So if you remember on a graph, these two lines would be parallel. And on number 8, they would be two lines that coincided or they are directly on top of each other. Okay, we have 2 word problems before we are done with these notes. So looking at number 10 here, notice that our directions first say we have to define our variables. So I'm going to have x equals something and y equals something. We need to ask ourselves, what are the 2 things that we're talking about? So we're talking about washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. So the things I notice is x would have to be cars and y would have to be trucks. Those are the 2 things that we're talking about here. Next, you have to write a system of equations. You've got to set it up. So 2 cars and 3 trucks takes 130 minutes. That would be our first equation here. So 2 cars would be 2x plus 3 trucks would be 3y and then equals 130 minutes to wash all of those cars. Then the second equation, washing 2 cars, 2x, and 5 trucks plus 5y takes 190 minutes. And then it wants to know how long does it take to wash each type of car. So now that we have our system written, our system of equations, meaning 2 equations written, I'm going to go ahead and start solving by elimination because that's what my directions say I have to do. So again, solving by elimination, you're looking for opposite coefficients. In this case, you have 2's, but they're not opposite. So I'm going to multiply the top equation by negative 1. So I get negative 2x minus 3y equals negative 130. and then lightly squiggle out that top one. We're not looking at that one anymore. And I'm going to go ahead and add these two equations right here. When I do that, my 2x's cancel out. I have 2y equals 60, divide both sides by 2, and y would be 30. Then again, I'm going to plug this into the top equation for y. So I have 2x plus 3 times 30, and then equals 130. So then I have 2x plus, this would be 90, equals 130. Subtract 90 from both sides. And we have 2x equals 40. Divide both sides by 2, and x would be 20. Now, because this is a word problem, we need to make sure we answer in words. So it would take 20 minutes per car and 30 minutes per truck. And that would be our final answer. So again, remember, with a word problem, we would not answer with an ordered pair. It needs to be an actual sentence, or not necessarily a complete sentence, but at least a thought on the paper about what the answer would be in words with labels would be my biggest thing. It's got to have the labels with it. Okay, we have one more word problem left on the last page. Let's go ahead and flip it over. Okay, for the last word problem here, again, define our variables. So I have x is going to equal something and y is going to equal something. A concession stand sold a total of 138 small and large popcorns. A small popcorn cost $2.50. A large popcorn cost $4. Total popcorn sales were $466.50. How many large popcorns were sold? So notice they only care about how many large popcorns were sold. They don't really care about small ones. So as long as we find that, we'll be good to go. So we have, let's see, two things we're talking about would be small popcorn and large popcorn. And then our two equations. So I see that they sold a total of 138 small and large popcorns. And then they have a sentence that talks about all of the money that was involved. So if you remember from the word problems that we've done in this chapter before, I'm going to go ahead and put all of my money in one equation because I only have those three numbers and then just one additional number after that. So I have 250x plus 4y equals 466.50. And then my second equation, I know that there was a total of 138 bags of popcorn sold. We just don't know how many of each. So it would just be x plus y. So when I'm trying to solve this by elimination, again, I need opposite coefficients. So I would rather not do anything with that 250. I'd rather not multiply by a decimal. So I'm going to go ahead and make this bottom y become a negative 4y so that it cancels out with the top 4y. So when I do that, I have negative 4x minus 4y equals negative 4 times 138 would be negative 552. So if I draw my line and add those together here, I would be adding the top equation and the bottom equation. Notice we are not looking at that middle equation anymore. So 250x and negative 4x would make negative 1.5x, and then my 4y's cancel out. 466.50 and then negative 552 makes negative 85.5. And then I'm going to divide both sides by negative 1.5. And then I get x equals 57. Now the problem is the question wants to know how many large popcorns were sold. And we actually only found x, not y. So we're actually going to have to plug it in to the top up here. And you know what? This would actually be the one time that I would go ahead and just plug it in down here because both of these have coefficients of 1. It would be a much quicker equation to plug it back into. So I will stand corrected on this one. I will not plug it back into the top one because the top one would actually end up being a lot more work in this case. So I have 57 and then plus y equals 138. All I'd have to do on this one is subtract 57 from both sides, and we get y equals 81. Since the question wants to know how many large popcorns were sold, we would just say 81 large bags
of popcorn. And that is it for these notes.